Hello dear students. In this video, let's continue implementing queue using linked list. In the previous video, we saw what do you mean by declaring a node and how are you declaring a queue which contains two pointers front and rear. Now let's take a look at main. From main, we are going to call two major operations, insert and delete. Of course, there are more operations like display, destroy, return. But two major operations which are done on queue are insertion and deletion. Now remember, in a stack, we don't say that we insert a value in the stack. We say we push a value in the stack. This is for stack. But in the queue, we say we are inserting a value. So both these operations are adding new data. But when you add a new data in the stack, we say it is push operation. And when you remove a data, it is called pop operation in the stack. Whereas in the queue, we say it is delete operation. So these two operations are going to be called from main program. But then two very important lines in main that you should concentrate on is this line. Struct QQ. How will you read this line? Here we say Q is a variable of type Q. Just as you say X is a variable here of type int. Like that, Q is a variable of type Q. Then Q will have its place in the memory and Q will contain, this variable will contain whatever Q contains. And what does Q contain? We have declared a struct called Q and we have said any variable of this type, any variable of Q type will definitely contain two members, front and rear. So this Q is going to contain two pointers, front and rear. What we have done by declaring this queue is that we have made a new queue in the memory. But right now, right now there are absolutely no nodes in the queue. Queue is empty. But when we insert a few nodes, front will point to the frontmost node inserted and rear will point to the last node inserted. But right now we have not created any nodes. We have only created this queue which contains front and rear. Now have a look at next line. After declaring this variable Q, which contains front and rear, we want to make it very clear to our program that there are absolutely zero nodes. There are no nodes in the queue yet. The queue is empty. We do that by making both the pointers. Remember, front and rear are pointers. And pointers are made null. Both pointers, front and rear, which are there in the queue, are made null. So front is null. Observe q dot front is null and q dot rear is null. By the way, this line is declaring a new queue in the memory or creating a new queue in the memory, and this line is initializing the queue to tell that the queue is currently empty. Okay. Now let's see the menu driven main again. In the main, we have do while loop where we are printing the menu and the options are 1 for insert, 2 for delete, 3 for display, 4 for destroy and 5 for exit. And if the user selects first option insert, then case 1 will execute in the switch, where in this case 1 we are asking the operator to enter the integer that operator wants to insert and we will scan that value in a local variable x. Let's say the value entered by the user is 10. So user has made it clear that in the queue 10 should be inserted. So here is the call now. Main function is making a call to insert. You observe the parameters passed to insert. We are passing address of queue and we are passing 10 because the value of x is 10. I hope you have come to this video after watching the stack using linked list video and also the linked list programs, singly linked list programs, which were taught before the stack topic. And you are aware of what do you mean by passing the address of the queue. But that's the call to insert. So I think we are now ready to see how insert function works. Here is the insert function written below main. By the way, when this insert function runs, I'm sure you all are aware that we have a queue variable which contains front and rear, and both of them are null. We did it in main, isn't it? Now, insert function is called by passing the address of the queue. This was the first parameter. And second parameter passed was the value of x, which is 10. So it is clear that p is a pointer which stores address of the queue. So p points to queue. Now, in this function insert, I can refer this front pointer in the function with the notation p arrow front. And I can refer this rear pointer with the notation p arrow rear. But I cannot write q dot front, neither I can write q dot rear inside this function. This is wrong. Why? You know the reason, I am sure. Because this variable q has been declared inside main. So q dot front and q dot rear, these notations can be written only in main. You know the concept of scope related to the variable. And such variable q which is declared in main can be used only in the main. So what trick we did is that we passed the address of the queue and stored it in pointer p. Now as p, observe the arrow, is pointing to q, we can handle q via p. I mean p arrow, this part, p arrow will take us to q. And once we reach the queue, it's so easy to access front. Okay, so let's execute this code of insert line by line. This is going to be very easy because you just have to see the lines and draw the diagrams and understand what assignments have been made. Before that, please excuse me, I am drawing this picture again. Q has front and rear and both are null. And this is the pointer P which has got address of the Q. So P stores the address of Q, so P points to Q. X is anyway 10, we are inserting 10. When you run this code, there is one more pointer newrec declared locally inside insert, which is a node pointer. So in the memory, there is newrec pointer, which is not pointing anywhere at the moment, but it can point to a node. You all know this line, newrec will now point to newly allocated node. Malloc will allocate a new node because we have asked for the struct node. So somewhere in the memory, there is a new node created or allocated. And the newrec pointer written on the left here of this assignment statement will point to this new node. What that means is this new node has two members, isn't it? Data and next. Don't forget that. Every node can store two things, data and next. Now the next line is newrec arrow data should be 10 because x is assigned. So here we go, newrec arrow, this data field should be 10. And next line is newrec arrow next should be null. Watch this, newrec arrow, new rec, arrow next, this next should be null. And indeed it should be, isn't it? What do you say? Have you understood one thing, that this is a queue that we are creating? And listen, there was nobody in the queue at the moment. Queue was empty. And this is the first person joining the queue. This person is 10. So will this 10 have anybody standing behind him or her? Obviously not. So next pointer has to be null. Next is we ask a very simple question. What is the condition of the front pointer? Is PRO front at the moment null? Just observe at the bottom of the screen. P arrow, P pointer, P arrow, front. We are talking about this front. Is it null? Yes, indeed we did that to begin with in main. In main, front was made null. So this condition holds true. And as this condition holds true, else will not run. But this line will run P arrow front equal to new rec. What that means is P arrow front should point exactly at the same node where new rec is pointing. Check this line again. P arrow front equal to new rec. So where is new rec pointing? New rec is pointing to 10. So front should also point to 10. What that means is now front won't be null anymore. Front is no more null. I hope you are understanding. Front was null. This condition was true. And as front was null, we knew that this is the very first node. So front, the header pointer, is pointing wherever new rec is pointing. And as you all know, else will not run, but this line will run, which I am currently underlining, because this is out of if else. And this line says P arrow rear should also point where new rec is pointing. Just observe P arrow rear. This P arrow rear, this rear we are talking about. And this rear should also point wherever new rec is pointing. And new rec is pointing to 10. So this P arrow rear also points at the same node. So what you understand is rear is not going to be null anymore. It was null to begin with, but now rear points to 10. And that's it. That ends the function. So let me clean up a few things. I know that the function has become a bit shabby, but that's the way how the explanation goes. Now the function has finished. Then some cleanup work is done. What C will do, it will delete those variables which were created for the function. Recall nurec was created inside the function, so nurec is deleted. And P was a parameter, so even this pointer P will be deleted. Correct? You tell me, aren't we having a perfect queue here? Check this queue. This queue is having only one value 10. There is no follower. So next of 10 is null. Now tell me, in this queue only one person is there. So don't you feel front should point to the 10 and rear should also point to 10? Yes, of course. This 10 is frontmost and 10 is rearmost. And that's exactly what we have achieved here. Okay, let's do practice on this. What if we call insert second time? Recall, we have only 10 in the queue at the moment. So we again pass the address of the queue and 20 has to be inserted. So currently queue which had front and rear, front is pointing to the node which stores 10. Sorry for this, wait a minute. 10, and this 10 has associated next which has null, and rear is also pointing to the same node. Now let's try to insert 20. Again P is a pointer which will point to Q because P stores address of the queue. Okay, let's run this. There is a new pointer called newrec. So there is a pointer somewhere in the memory called newrec, and remember newrec can point to a node. In the next statement, newrec points to newly allocated memory and a new node is created. So somewhere in the memory, new node is created. Remember, this can store data and next because it is node, and this new rec pointer will point to this node, newly created node, isn't it? Now the next statement, new rec arrow data should be 20 because it is assigned x. So here we go, new rec arrow data, this data should be 20. And the next line, new rec arrow next should be null. Watch this, new rec arrow next, this next member should be null. And indeed it should be. Because you tell me earlier there was only 10 standing in the queue. Yes, I agree that at that moment 10 was the last person. But now somebody else is joining the queue, 20 is joining the queue. So don't you feel that 20 should not have anybody standing behind that? What is the change needed now? You tell me. Just pause the video. You want this to be a queue now. I mean, you can't have 10 and 20 standing separate with no connection between them. Yes, you got it. This next pointer of 10 should no more be null, but this next pointer should point to the node which stores 20. Isn't it so? Any other change? Yes, you said it. This rear should not point to 10. Come on, who is the rearmost now? Rearmost is 20. But what about front? Front should still point to 10. Seriously, 10 is still the frontmost. But now 20 is the rearmost. So are you understanding? We have to do two changes. One is, first change is next of 10, which was null, should now point to 20. And rear, which was pointing to 10, should now point to 20. And I hope that now, after learning stack, after learning linked list to some extent in the previous videos, you don't need help on what happens at these two lines. First of all, let's see this if. We ask, is front null? No, not at all. Front is pointing. Front is pointing to some node. So as this condition is false, we know that there are some nodes existing in the list. That means the node that we are inserting is not the first node. So as this if is false, we will go to else and have a look at this line. P arrow, rear arrow next. Just follow these pointers. P arrow, rear, this rear, arrow, next. Here we got this next, isn't it? What should happen to P arrow, rear arrow next should become equal to new rec. That means wherever new rec is pointing, check this, wherever new rec is pointing, this next should point to the same node. So it won't remain null anymore. It will point wherever new rec is pointing. So that's the else portion. And anyway, this line which I am now underlining is out of if else. This will anyway run, which says P arrow rear should become equal to new rec. So we are asking rear to change its position. Rear pointer should change its position. Rear pointer should no more point to 10, but rear pointer should point wherever new rec is pointing, and hello, new rec is pointing to 20. That's it. After that line, the insert function ends. But you also don't forget that there is some cleanup work done. Yes, everyone. What will be deleted? This new rec variable is deleted and this p is deleted. Look at that. We are having a queue with exactly two nodes because we have done two insertions till now, correct? And 10 was inserted first. So obviously 10 is the front. Front is pointing to 10 and 20 was inserted just now. So 20 is pointed to a rear and 20 is the last node. So it doesn't have any follower. So next is null. Great. That's the way how the insert works. Now I'm not going to run through this code again, but just tell me if you want to insert 30, what would you do? I don't want you to now read these statements, but just tell me in English. What would you do? You will create a new node, let nurec point to that new node by using malloc, and nurec arrow data should be x, that is 30, and nurec arrow next should be null. Come on, this is the last node now. This is going to become the last node. Now the change you will require is this next of 20 should point to 30, correct? How will you do that? First of all, you will have to reach this next. Well, who is pointing to this next? Of course, rear is pointing to this next. But then there is a pointer called P which points to this entire block. So you will write P arrow rear, arrow next. So you have reached this next. Should be equal to new rec. Should be equal to new rec. And new rec, as it is pointing to 30, this next pointer will point to 30. And now this next is no more null. Yes, everyone. Correct. What is the other change that is needed? Check this rear. How can this now point to 20? This rear should now point to 30. But how will you ask rear to point to 30? You will say rear, you point at the same node where nurec is pointing. That means you have to make this rear equal to nurec. So you say P arrow rear. First of all, you reach that rear. P arrow rear equal to nurec. That's the last line here, isn't it, in the insert function? So now the pointer rear is no more pointing to 20, but it's pointing to 30. And obviously, when this insert ends, nurec and this pointer P is deleted, and we have a perfect queue where we have 3 nodes with 10 as the frontmost and 30 as the rearmost. And look at them, they have perfect link between each other. That's it for the insert function. When we come back in the next video, I will tell you about delete operation. Thank you very much.